Hello! In this video, I'm going to dive into several major aspects of Microsoft Security Objects, the CubicleSoft command line get token information tool, and finally, several mechanisms of the CubicleSoft command line create process tool to create processes in a way that's never been done before. Let's get started! Windows security objects are advanced, flexible structures that are their own Achilles heel. Very few people who develop software applications for Windows understand how Windows works under the hood to implement system security. So let's gain a better understanding of the underlying components of system security in the Microsoft Windows OS. Security in the Windows OS can be broken down into four major categories: security tokens, security identifiers or SIDs, privileges and rights, and access control lists or ACLs. For comparison, security in most other OSs can be broken down into three major categories: users, groups, and read, write, execute access permissions. The simpler and easier to understand security structures of other OSs naturally keep those OSs more secure from security breaches. The superstructure of security in Windows is the security token, usually just referred to as an access token or token. A number of common tools in Windows look at security tokens of processes to display information. For example, the Details tab of Task Manager shows what user is running a process. That information comes from the process security token. Every running process in Windows has a primary security token, and every thread in a process may optionally have an impersonation security token. Primary tokens are assigned at process creation and can't be reassigned after the process starts running. Impersonation tokens can be assigned and removed from threads as needed. With sufficient privileges, tokens can be duplicated using the Duplicate Token X API and converted between primary and impersonation tokens. Tokens contain a user SID, one or more group SIDs, an owner SID, a primary group SID, the list of privileges assigned to the token, and much more. A really useful function for accessing the contents of a token is the generic getTokenInformation API. Windows comes with a command line tool called WhoAmI that can dump some aspects of the current user's security token. For example, WhoAmI/priv dumps my current user's security token privileges. WhoAmI may be included with Windows, but there is a much better tool available. The CubicleSoft getTokenInformation tool dumps detailed token information as JSON, which makes its output consumable by almost any programming and scripting language. But more importantly, it dumps all available token information contained in a process or thread security token, allowing tokens to be fully analyzed. Let's look at the contents of a security token. First, we can see my current user security identifier, or SID. SIDs are how Windows uniquely identifies users and groups. The binary structure of a SID is rather complex, which makes it more natural to view SIDs as encoded strings, as seen here. For real user accounts, additional information can be obtained using the CubicleSoft getSIDinfo tool that also dumps detailed information as JSON. We can also see which group SIDs and attributes are available in this token, the integrity level that the process is running as based on one of its group SIDs, and both the owner SID and the primary group SID of the process token. Next up is everyone's favorite nemesis, privileges. Privileges in Windows grant access to specific APIs or bypass various security measures. An example of this is the SE change notify privilege, which allows a process or thread with the privilege to bypass directory traversal checks. Users in the Windows Administrators group have SE change notify privilege by default, which grants access to all the files and directories on the system. Given what SE change notify privilege actually does, it is a rather poorly named privilege. Another example of a privilege in Windows is SE debug privilege. SE debug privilege allows the current process or thread to open a handle to almost any other process or thread for purposes of debugging it. Let's see an example of this in action using the getTokenInformation tool. From an administrator command prompt, I can use the getTokenInformation tool to dump information about an INT authority system token. GetTokenInformation is able to retrieve information about other process tokens because the administrator user has SE debug privilege by default. Even though we are not actually debugging the target process, we can open a handle to it and then obtain and even possibly copy its process token. Once again, SE debug privilege is a poorly named privilege since it can do things like enable copying of security tokens. While privileges can be removed from tokens, there is no known way at this time to add privileges to an existing token. Tokens that do have privileges tend to disable the privileges by default. To use a privilege in a token, a process must first modify its own token to enable an existing privilege that it already has. Then the process can successfully call the API that requires the privilege. Microsoft is notorious for both poorly naming privileges and also not properly documenting all of the privileges required to both exist on a token and be enabled to call privileged APIs. This is why we can't have nice things. The last topic to briefly cover before getting to the fun part of this video is access control lists, or ACLs. Windows has two types of ACLs, system ACLs, or SACLs, and discretionary ACLs, or DACLs. SACLs are used for logging access attempts in the Windows event log, while DACLs are used for controlling access to an object. ACLs are made up of 0 or more access control entries, or ACEs. Every token has a default DACL associated with it, which declares who and what can access the token. Building and modifying ACLs is its own painful and rather lengthy topic due to their complexity. Case in point, binary ACLs can be serialized to and deserialized from compact, mostly incomprehensible strings using two awkwardly named functions that also happen to have the two longest names in the Windows API. In general, the details of a default DACL associated with a token is of little actual importance for our purposes beyond having a valid DACL. Now that we've learned a little about security tokens, SIDs, privileges, and ACLs, it's time to take that knowledge to a whole new level. We've seen that we can use the getTokenInformation tool to retrieve and dump existing tokens. With the login option of getTokenInformation, it can dump token information for another user once the user enters their login credentials. With the Create Token option, a primary token can be made that is similar to the earlier login token, but doesn't need the user's login credentials. The Create Token option calls an undocumented Windows kernel API known as int create token. int create token creates new tokens from scratch with almost any combination of SIDs and privileges. However, calling the int create token API requires SE create token privilege. SE create token privilege is one of the few privileges in Windows that actually does exactly and precisely what it says on the tin. Unfortunately, very few processes have SE create token privilege, and obtaining it requires completing a somewhat complex set of steps. To call the int create token API, the getTokenInformation tool enables SE debug privilege, scans through the running process list and finds a process with SE create token privilege, duplicates that process's primary token as an impersonation token, enables SE create token privilege on the duplicated token, applies the impersonation token to the current thread, processes the token options from the command line into complex binary structures and validates them, and finally calls the int create token API. It is also possible to successfully create a primary token for a user that is not actually a member of the administrators group, and give it some pretty powerful privileges that even administrators don't get. In other words, we can create a slightly broken token. Note that I had to be elevated as administrator to do this on the system, which I actually consider to be okay because administrators should be able to do anything on their own systems, including unusual stuff like this. Back in 2008, I figured out how Windows Vista UAC elevation worked and published an associated and rather lengthy article on Code Project. The knowledge from the article continues to be useful in modern Windows software development. To summarize, a non-elevated process sets up a named pipe server that the elevated process will connect to in order to receive instructions. Then it calls shell execute X with the run as verb, which triggers an elevation prompt, which starts a new elevated process using the linked security token of the user. The elevated process connects to the named pipe, receives instructions on how to call the create process API from the original process, calls the create process API, and finally sends the results of the call back to the original process. One of the key takeaways from the article is that Windows checks the integrity level of a security token when opening handles to objects such as named pipe servers. Processes with a higher integrity level can access objects at the same or lower integrity level, but not vice versa. As a result, an elevated process can connect to the named pipe server of a non-elevated process to receive instructions on how to call the create process Windows API from the elevated process. The exception to the rule is that if the process has SE debug privilege enabled, it bypasses such checks. There are some significant downsides to the 2008 method of handling elevation. First, for console applications, the elevated process creates a brand new console window instead of reusing an existing console. Second, various handles like standard in, standard out, and standard error, and other normally inheritable handles can't be passed to the child process. And third, passing standard create process options and properly handling errors requires serializing complex structured data across a named pipe, as well as to avoid hitting OS command line length limits. Fast forward a little to 2012, the uncreatively named CubicleSoft command line create process tool was made to precisely start processes by calling the Windows create process API. It's been used quite a bit since 2012 for a variety of projects, and has received a number of updates, such as the ridiculous ability to route standard in, standard out, and standard error over TCP/IP sockets. I recently decided I would add the 2008 method of starting an elevated process that communicates various details over a named pipe. I went ahead and did that. But then I had an idea. There is now a brand new way to create child processes on Windows that no one has ever done before. With the latest version of the CubicleSoft Create Process tool, it can start a command prompt or PowerShell or another executable as the powerful system user, which offers new and interesting ways to debug system services. Or start the Create Process tool as an elevated child without the issues from the 2008 elevation method, and then run an executable with the XML manifest of a require administrator as a grandchild. Or start a child process of a non-elevated process as another user account without requiring that user's login credentials. Or even create the slightly broken token from earlier and start a child process with it just for funsies. The possibilities are quite extensive and enable powerful, brand new, never-before-seen functionality for Windows OS process creation. So how does it work? Behold the crazy. When using the new System Token, Elevated Token, Use Token, and Create Token options, the Create Process tool first determines if its own process is running as a plain old regular user, an elevated user, or as NT Authority System. If the process is a regular user, it follows the regular user path of this diagram. The first process sets up a named pipe server, and then calls shell execute X with the run as verb to display the elevation dialog. The resulting elevated process then creates and starts a temporary NT system service. The NT system service starts another create process instance which connects into the named pipe server to receive instructions and communicate information. Enables 4 necessary privileges on its primary token and communicates success failure status back to the first process. On success, the token information to use is passed from the original process to the system service process. The system service then attempts to duplicate an existing token or create a new token as directed. The system service then thanks the elevated process for its service. The elevated process marks the system service for deletion and then cleans up and exits. The system service then attempts to load the network profile and registry hive of the associated user. This is so that the child process that will be created can have access to all of the user's resources. And finally, the system service creates an environment block, which it passes back to the original process. The original process then receives the environment block and optionally merges the current environment block with the user's environment block. This allows custom environment variables to be passed from the original calling process onto the child process that will be created momentarily. Then, the actual child process is started as a suspended process using the createProcess API. Upon success, the process ID is passed back to the system service. Note that while the newly created child process exists, it won't show up in Task Manager at this point since it was started suspended. The system service then opens a handle to the newly created process. Then it calls the undocumented Windows kernel int_set_information process API to assign the primary token that was duplicated or created earlier. Note that once a process starts running, its assigned primary token can't be replaced. Upon success, the original process starts the main thread of the newly created process. Voila! A child process of a non-elevated process is now correctly running with a different security token, all without requiring the associated user's password or other login credentials. If the process was started already elevated but not the system user, elevation is skipped, and a slightly different but similar set of steps take place. If the process was started running as the system user, the core set of steps are handled directly within its own process. The complete diagram seen here is linked to from the CubicleSoft createProcess Tools README file. Note that this capability has existed since Windows NT, and that on Windows Vista and later, the sequence of steps requires elevation for this to work. However, we can surmise that the reason that no one has ever done this before is due to a prerequisite in-depth understanding of how Windows elevation works under the hood, the requirement to fully comprehend Windows security objects, tokens, SIDs, privileges, etc., the required knowledge and correct use of at least one undocumented Windows kernel API, int_set_information process, and probably int_create token. The requirement for a dedicated executable whose sole purpose for existing is to start processes, spending 3 months to conduct all of the necessary background research and development. Most of the research resulted in dead ends, or infinite loops of logic on MSDN and Stack Overflow, or barely provided the vaguest of hints. I didn't even know if this was going to work until it actually worked. And, of course, I also ran into some OS level bugs that wasted a bunch of time, because this is Windows. Having to start up to 3 distinct processes with unique purposes, which also includes an NT system service. All of that just to start one child process. And significant risk that something could go horribly wrong somewhere, because if something can go wrong, it probably will. Unless you are on the Microsoft Windows OS kernel development team or a React OS kernel developer, as promised, your brain has now been properly melted. Check out createProcess, get token information, get SID info, and over 80 other useful CubicleSoft libraries and tools over on GitHub. Hopefully you learned something new today. And, as always, be sure to like and subscribe, and thank you for watching.